Hi students, this is Mr. Yao. Today we're going to talk about 9.5, where we'll learn how to use trig functions to solve story problems. First, let's look at some definition. Angle of elevation. The word elevation means, elevating, you're going up. So that is the angle made by the ground and your line of sight to an object above you. So if you say the object is at the top of the building and you're trying to look up, since the building we typically talk about are pretty high up, so we ignore our own height, so we just use the ground, and this is the angle of elevation. Then, of course, on the contrary, we also have angle of depression. That is the angle made by the horizon of where you stand and your line of sight to an object below you. So this time the object is here, and you are standing right here, and you are looking down at something. This is the angle of depression. Then something else that is also used with trig is navigation, and that's where we talk about compass bearing. That is the direction toward which you are headed, as shown by a compass. It is commonly written in the form of, this means north 6 degrees towards the east, meaning the bearing that makes us an angle of 6 degrees with north towards east. So, for example, this is the north, up north, this is the north. The direction you're actually going is right here. So it's from north and turns 60 degrees towards east. And we typically say the east and the west later after the north and south. So we say north and south first. And since it is going down this direction, we're just going to start with south, then east. The angle will never exceed 90 degrees. Now let's look at some practice and example. First one, let's practice writing some compass bearing. So for point A, we always start from north or south, and this time you see the arrow is pointing from north, so it's north. Then it turned 30 degrees, so it's north 30 degrees towards east. Which means you need to know is up north, down south, left, west, right, east. And for point B, it's still from north, but this time it's turning to the left, so 60 degrees towards west. For point C, south 70 degrees towards, and for D, south 80 degrees towards west. Next, for the rest of the examples, we need to draw a diagram of each of the questions and then write an equation, then solve. And you will notice it's actually more important to make sure you understand the question and draw it correctly. Otherwise, you won't even be able to see your right triangle, and then you won't be able to solve the questions correctly. So a ladder should be placed at an angle of 75.5 degrees against the wall. So here's a wall, and let's say here's your ladder. And that ladder is placed at 75.5 degrees against the wall. And if this part is actually 10 feet, if this part is 10 feet, so the ladder is actually 10 feet, is asking how far up will the ladder actually reach. So it's asking for this section. So now we have our right triangle because the ground and the wall is actually 90 degrees. And if we're using the angle 75.5 degrees, this will be the adjacent, so this will be the opposite, and that's the hypotenuse. And the trig ratio that needs opposite and hypotenuse would be sine. So sine 75.5 degrees is the opposite, which is our question mark, over 10, which is the hypotenuse. And then, of course, the rest is solving. You can do over 1, your cross multiplication, or you can just multiply by 10 on both sides. Question mark is 10 times sine 75.5 degrees. Says round to the nearest tenth, it's going to be 9.7. That's example 2. Example 3. From a boat on the lake, the angle of elevation to the top of a cliff. So let's say this is our cliff right there. And our boat is, let's say this is where our boat is. And the base is 1366 feet from our boat. And the angle of elevation, so we're looking up from our boat, the angle of elevation is 13 degrees. It is asking how high is the cliff. So if you see, this is the opposite, this is the adjacent. So the trig ratio we need is tangent. Tangent 13 degree is the question mark over 1366. And we can put it over 1 or multiply both sides by 1366. The question mark 1366 tangent 13 degrees. And that would give you 315. That is example 3. Example 4. From a hot air balloon 910 feet high. So let's say this is our hot air balloon right there. So let's say this is the point. And that is 910 feet high. 910 feet high above the ground. And angle of depression. So let's say this is the headquarters. Angle of depression. So this would be our horizon, which is the outside, and it's looking down. So this angle is 64 degrees, and is asking how far is the headquarters from the hot air balloon. So this side. And if you notice, the horizon and the ground are actually parallel. So by alternating interior angle, this would actually be 64 degrees as well. If that's 64 degrees, this is the opposite side, that's the hypotenuse, and that means we need to use sine. So sine 64 degrees is equal to opposite 910 feet over hypotenuse, which is our question mark. So put it over 1. So question mark times sine 64 degrees equals to 910 feet. The question mark will be 910 feet over sine 64 degrees. And that means the question mark would be 1012.5 after solving. So that's how far the headquarters is from the air balloon. That's example 4. Example 5. A sledding run is 400 yards long. So this is a sledding run, 400 yards long, with a vertical drop of 40.2 yards. Of course, the vertical drop forms a 90 degree with the ground, and is asking to find the angle of depression of the run. And the angle of depression is actually from here. So from the horizon to the line that's going down, which also means we're solving for this angle. They are the same. So if that's the same, that's opposite, that's hypotenuse. Sine again. So sine, let's say that's actually theta. Sine theta equals to opposite 40.2 over hypotenuse, which is 400. So theta is inverse sine of 40.2 over 400, which would actually be 5.8 degrees. That's example 5. Example 6. A sailboat leaves the dock at a bearing of north. So let's see, this is north, and it's 37 degrees east. So that's where the boat is actually going at first. And then it says travels a distance of 100 kilometers. After that, the boat turns and travels due south. Due south actually means it's going toward south. How far does the boat need to travel in order to be due east of the dock? So dock is right here, that's our dock. Due east means it's directly to the east of the dock. So this is the east side, and that is going to form a right triangle with the line that the boat is traveling when it's due south. And is asking how far it needs to travel to be exactly due east to the dock, to reach that point. And if that's 37 degree, then this would have to be 37 degree, and that's the adjacent, and that's the hypotenuse. So we use cosine. 37 degrees is the question mark over 100, which is the hypotenuse. And then we can multiply both sides by 100. So the question mark is 100 times cosine 37 degrees, which is 79.9 kilometers. That's example 6. Example 7. two planes leave from the airport at the same time. So plane A, let's say this is plane A first, south 45 degree. That's 45 degrees south, 45 degrees towards west. And it's traveling at 527 miles per hour. That's plane A. And plane B is traveling north 45 degree west. So towards that direction. And if you notice, since these two angles are both 45, that means the rest of the angle, this actually is 90 degrees. So it's a right angle. And by the way, this is where plane B is. Then it says after 2 hours, how far apart are the two planes? So let's say what we draw actually represents how far they traveled in 2 hours. It's asking how far apart are they after 2 hours. So this is what we're solving for. Travel for 2 hours for plane A at 527. So 527 times 2, that is 1,054 miles. And for plane 2, 650 times 2, that's 1,300 miles. So this side is 1,300 and this side is 1,054. And we have a right angle you're trying to find, in this case, the hypotenuse. So Pythagorean theorem, 1054 squared plus 1,300 squared. Add together, then square root the answer. That will give you 1673.6 kilometer. And that is, not kilometer, mile. And that is how far away the two planes are after 2 hours. That's example 7. Example 8. A person is watching a boat from the top of a lighthouse. Let's say this is the top of a lighthouse. And of course, there's a certain height of the lighthouse. And it's watching a boat. The boat is approaching the lighthouse directly. So let's say this is our boat at first. When first noticed, the angle of depression is 18 degrees. This is the horizon. And it's depression, so it's looking down, which means this line and our horizon is going to form 18 degrees at first. Then the boat kept traveling until it stops. The angle of depression is 50 degrees this time, so our boat is now around here. Because this angle, the new angle of depression is 50 degrees. The lighthouse is 200 feet tall. Is asking how far did the boat travel. So this is the section that is actually asking, this part. How far did it travel? And you will notice this is a right angle. In order to find how far it traveled, you need to find out how far is this, subtract how far is the boat from the lighthouse when it stops. And then you can subtract them. So let's look at the bigger triangle first. This triangle right here. That's the bigger one. And if the angle of depression at first is 18 degrees, same thing, and the horizon and the ground are parallel, so this angle must be 18 degrees because they're alternate interior angles. So if we look at the triangle, let's say this whole thing, this right here, that's the opposite to the 18 degree, and this side is actually the adjacent, which means we can use tangent. So tangent 18 degrees is going to be opposite, which is 200, over, I'm going to call this A1 because this is the first adjacent side, so over A1. Then of course you can find A1 by 200 divided by tangent 18 degrees. Now let's look at the second triangle, which is right here. And I'm going to call that side A2. Because if this is 50 degrees, that must be 50 degrees, since it's alternate interior angle. Then I still have this as my opposite side, but this is in the adjacent side, so I call it A2. Tangent 50 degrees equals to 200 over 8. After solving, A2 is 200 over tangent 50 degrees. And of course, what I'm trying to find, the question mark, is A1 minus A2. So the question mark is A1 minus A2, which is 200 over tangent 18 degrees minus 200 over tangent 50 degrees. After solving, that's going to give 147.7 feet. And that's how far the boat actually traveled after it's first noticed. That's example 8. The last question I will talk about is actually the homework question number 11. And this is a tricky question, so I will talk about it. A DC-9 aircraft leaves Midway Airport from a runway whose bearing is north. This is north, and it's 40 degrees east. So let's say this is 40 degrees and towards east, right there. After flying for half a mile, the pilot requests permission to turn 90 degrees and head towards southeast. Southeast. Down south, right is east, so it's actually towards that direction. So it turned and then kept going. This is 90 degrees. And it's going southeast now. The permission is granted after plane goes 1 mile in this direction. So this time it went 1 mile in this direction. What bearing should the control tower use to locate the aircraft? So that's where the aircraft is. And of course, you can connect them to actually make the triangle. In order to find the bearing, we first need to find what this angle is. And I'm going to call it theta. Okay, so if that is the theta, I can identify this is my opposite, this is my adjacent. So I'm going to need T tangent. And tangent theta is opposite, so 1 over adjacent, which is 1/2. 2. So basically, my theta is going to be inverse tangent of 2. And inverse tangent of 2 is actually going to give you 63.4349 degrees. So this angle actually is 63.4349 degrees. However, it's asking you to find the bearing. And since we clearly can see this angle, whole thing is going to be more than 90 degrees away from the north, that means we need to actually go from the south. So in this case, I'm going to extend the line. So this is my south, and I'm trying to find what is this angle so that I can write the bearing. And if I know that's 40, that's 63.4349, I can use 180 minus 40 minus 63.4349. So that is going to give me that is going to give me 76.5651 degrees. So in this case, the bearing is going to be south, 76.57 degrees. Again, in order to actually write the bearing, we got to start from south or north. Since we cannot start from north because the angle is going to be more than 90 degrees, 40 and 63 together is like 113. So we got to go from the south. And if it's going from the south towards the east, we got to find this extra angle, and that's what the bearing is going to be. So south, 76.57 east. That is everything for 9.5. Thank you.